Howdy, my name is Ryan Cho, and today I'm going to be teaching you about Le Chatelier's principle. So the very first thing about Le Chatelier's principle is that no solids and no liquids are ever used, and that is because solids and liquids don't have concentrations unlike solutions and gases. Now that we have that set aside, let's start off with the principle. So whenever you increase a concentration of any side from the reactants, it'll shift the equilibrium to the right, and that's because the extra concentration that we added needs to be used up. So if you increase N2 or H2, it'll shift right. If you increased NH3, it will shift left to the reactants. So the same can be said if you decrease it. It's just the opposite. So if you decrease N2 or H2, it'll shift left. And then if you increased or if you decreased NH3, it will shift right. So, and that's the same thing, basically needs to produce more of the substance in order to make up what was removed. So therefore it shifts to whatever is being removed. Now on to pressure. So whenever we increase the pressure of the system, we need to look at how many moles of gas there are on the reactant side and the product side. So over here we have 1 mole of N2 and 3 moles of H2. So therefore we have 4 moles in total of on the reactant side, and we have 2 moles in total on the product side. So when we increase the pressure of the system, equilibrium will shift to the right, and that is because there are less moles on the product side. Now, if we decrease pressure, it's going to shift left, and that's because it's going to shift towards more moles of the gas. So there you go. And then if you're going for volume, it's just the opposite. So if you increased pressure, it'll shift left, or if you increased volume, it will shift left. If you decreased volume, it will shift right. In the sense that it's set up like this. Now on to temperature. So if we have an exothermic reaction, which is adding heat, my bad, that should be heat. So if we have an exothermic reaction and we increase the temperature, we will shift away from the heat slash energy. So an exothermic reaction is favored, basically shifting it to the, oh wait, sorry, my bad, to the left. And then if we decrease the temperature, it will shift towards the heat for an exothermic reaction. And then endothermic is just flipped, so this will be, oh, my bad. So for this is for an exothermic, and then for an endothermic reaction, it will be if you increase the temperature, it will shift right, and if you decrease the temperature, it will shift left. And then the last thing are catalysts. There's no shift ever in equilibrium whenever you add a catalyst, it just lowers the activation energy.